Hello guys, I'm Paul McWhorter and I'm here with lesson number 10 on the Arduino microcontroller. And what we're going to be doing today is we're going to be looking at how to read analog voltages off of your circuit using the Arduino. And if you think about it, with all of our exercises so far, we've been working with these pins down here. Those are the pins 1 through 13. These are pins that we write voltages to. We remember that the pins that don't have a squiggly line, we can do digital writes to. That would be a digital write to that pin high or to that pin low. But if we use the pins that have the squiggly line by them, we can actually write an analog voltage. And we write an analog voltage by writing a value between 0 and 255. If we write the value 0 to one of those squiggly line pins, we write a 0 volts. If we write a 255, we write 5 volts. So we can write voltages between 0 to 255 on pins 3, 5, 6, 9, 10, and 11 along that bottom row. The other pins we're able to just write, only able to write digital values to high or low. Okay, but so far all we've been doing with our circuit, well, we've been talking to the user over the serial port, printing messages to him over the serial port, and then getting input from him over the serial port. So we can interact with the user, and then we can make things happen to the circuit. We can apply voltages to the circuit. We can apply digital voltages, or we can apply analog voltages. So those are the things that we've learned so far. But what we're going to do today is we're not just going to be talking to the circuit, we're going to be listening back from the circuit. We're going to be going out and making reads. We're going to be reading voltages off the circuit. And to see how to do this, we want to start with like the simplest example possible. So basically what we have here is a potentiometer. If you're not familiar with how a potentiometer works, go back and watch video number 9. In video number 9, we go through some of the circuit diagrams for how to work with a potentiometer and how to make a simple voltage divider. This is just a quick schematic of the voltage divider that we're trying to achieve. The voltage in is basically just a fixed voltage. It's 5 volts. The way in this circuit that we're getting the voltage in is we're coming off and we're getting 5 volts off of the Arduino from the 5 volt pin, coming down and just establishing a 5 volt rail on our breadboard. Then we bring that 5 volts and we go to the top leg of the potentiometer. So the 5 volts comes and goes to the top leg of the potentiometer. Where we're going to read is we're going to read the voltage off the center leg of the potentiometer. So you can see this is the center pin on the potentiometer, and we're going to bring that up to the analog pin 0, which is right here. So by coming from the center pin of the potentiometer up to A0, it's going to be that A0 pin that we use to read a voltage off of the potentiometer. And then down on the lower leg of the potentiometer, we bring that over to our ground rail, and that ground rail is our top row. And so we bring that third leg up to the top row, and then that top row we connect to ground on the Arduino. And so basically what we create is a very simple voltage divider that's shown here. And what the resistance, this RP, is the resistance of the potentiometer. Let's say for this it's 1,000 ohms. Well, basically that 1,000 ohms is split between R1 and R2 depending on where you have the knob set. If you have the knob set all the way to the left, all the voltage appears as R1. There is no R2, and therefore the voltage out is going to be 0. It's going to be like you're looking at the ground. If you turn it all the way to the right for this particular potentiometer, it puts all the resistance as R2. There is no R1, and V out sees V in, so it would see 5 volts. So basically with this circuit, our V out is the center leg of the potentiometer, just like you see here, the center leg of the potentiometer. And by hooking this circuit up like this, what you should see happen is if you read a voltage on pin A0, you should be able to vary that voltage between 0 all the way up to 5 volts by turning this little knob. Okay, if I turn it to the left, I should be getting 0 volts, and if I turn it all the way to the right, I should be getting 5 volts. Okay. Now, one of the things to understand when we do an analog read, it's kind of like, remember when we did the analog write, that things were scaled, and so if we wanted to write 0 volts, we would write 0. We would write a value of 0. If we wanted to write 5 volts, we would write a number of 255 to that pin. So a write value of 255 corresponded to a voltage of 5 volts. And so we had to scale things. Well, when we do analog readings, we have to scale things as well, although the scale factor is a little bit different. The analog numbers, the numbers that we will read off of that analog pin, will be between 0 and 1023. Okay? If we connect and try to read 5 volts, the read value that we will get will be 1023. If we read 0 volts, the read value that we will get will be 0. So basically, for voltages between 0 and 5, we will get read values between 0 and 1023. And so you've got to scale that number that you read that's between 0 to 1023, you've got to map it on the number 0 to 5. And we'll go through the math on that in a minute. But for right now, let's just see if we can make a measurement on this voltage divider, on this potentiometer, and let's see if we can get values that are what we're expecting. Let's see if we can make this thing work. So in order to do that, what we need to do is we need to call up a nice new Arduino integrated development window, and we will start writing some code here. Well, if we're going to talk to pin A0, if we're going to work with pin A0, we probably should assign a variable to it so that we can go through and write our program based on using that variable. And so what we can do is we can set it up as an int. And then what am I going to call it? Well, it's hooked to my potentiometer, so I'm going to call it my pot pin. All right? And that's going to be equal to A0. Let me try it this way, A0. All right? Now, the thing to understand is normally anytime you do an integer declaration, you would just put a number in here, but it's unique that it will recognize as integers those pin names, and we are connected to pin A0. Yes, we are. Okay, and then what we are doing is we're assigning pot pin to A0. We try to be good and put our comments in here. Now we're gonna be reading from that pin, so we're gonna need a variable to put that number into. So we need to declare a variable. It's going to be an integer, and we're going to call that our read value. So the value that we read from pin A0, we're going to call that read value. We're declaring the variable here, but we're not assigning a value to it because we'll get the value from the pin. We'll go out and we'll read it from the pin, so we're not assigning it here. But we are declaring our read value variable. Okay. Now, let's do our pin modes. Let's come in our void setup. Which pin are we going to be doing? We are going to be working with our pot pin. Okay, that's pin A0. But what is it going to be? Always up until now, our pins have been output because we've been outputting to the pins. This pin we're going to read from, so this is going to be an input. So we're going to say pin mode, and then it is the pin pot pin, and it is going to be an input. I think this is the first time we've made an input variable. Also, we are going to be working over the serial port, interacting with the user, so we need to turn the serial port on. So we'll do our serial.begin, and I'm going to go to a 9600 baud this time, right? Just make sure that whatever baud you use, it matches the baud that's set in the serial port, in the serial monitor, okay? I've declared my variables. I've done my pin mode, and I've started my serial port. So what can we do down here? Well, let's see if we can make a reading off of that pin. So the way to make an analog reading is you do analog read. Notice the bumpy font, and the R is uppercase. So analog read with R uppercase. You see it turned orange. It says, I recognize that command. It's happy. And then what pin are we going to read? We're going to read pot pin. Okay. Now, that does the read, but the value that we get, we've got to put somewhere. Well, where are we going to put it? We're going to put it in our variable read value. So read value is going to be equal to analog read of pot pen. So read value is our variable, that's our bucket. Where do we get our number to put in that bucket? Well, we get it from over here at this analog pin. So we do an analog read of pot pen. So I go out to A0 pot pen, I read a value, and then I stick it in my bucket, and the bucket is labeled read value. So the Arduino has the value at that point, but let's print it out so the user can see it. We'll do a serial.print line, print ln, and we're going to print the value, read value that we just read, and then boom. Now this can go so fast we want to slow it down so we can see the numbers coming up. So we're going to put a delay just so that we can sort of see the numbers going by. 250 milliseconds is a quarter second, and to me that's a good value to use. Okay, so we declare our pin, we create a variable called read value, we do our pin modes, we turn our serial port on, and look, I have not done comments. I better go back and put my comments on. And it's just good practice, right? Let's get in this habit, whether it just seems silly sometimes or not. Declare pot pin and input, and then start your serial port. Okay. Read pin, read pot pin, and put value in read value. Okay, so that's the bucket we're going to put it in. We're going to come here and print results to serial monitor, and then delay 250 milliseconds. All right. So what this should do is when we download it, it should just go out and start making measurements on this potentiometer. And what value it will read should depend on where the little knob is set at. So let's see if this is going to work. Let's see if I did my code good. Look at that lot of green down here. It looks like it's happy. Everybody's happy. So let's turn our serial on and let's see what we get. It's reading 0, and the reason it's reading 0 is I'm turned all the way to the left, and when I'm turned all the way to the left, all of this resistance RP shows up as R1. This is down here, and you're just seeing 0 volts, so it's reading 0 volts, and it's reporting that as 0. What happens if I start turning this to the right? If I start turning it to the right, you see I start seeing bigger and bigger and bigger numbers. As I slowly turn it to the right, I'm getting more and more and more resistance coming from up here down to here. So this is like not pointing down here, it's pointing further and further and further towards the top. 526, I'm about halfway there, because remember, 0 to 5 volts will read 0 to 1023, and so a value of 526, 527 corresponds to about 2.5 volts. So I'm about halfway to turning it all the way to the right, and so I'll continue to turn it here. You can see growing, 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 and then I turned it all the way to the right, and I get it all the way up to 1023. When it's reading 1023, that corresponds to a voltage of 5 volts. You know, everything scales from 0 to 1023 represents numbers from 0 to 5 volts. Okay, so now what you can see here is that I have a little input device, and the number that I get on my serial monitor depends on where I set this potentiometer. Like I have a little knob, like that could be a volume control. Now I could set the brightness of the LED based on where I put this, or I could set other things based on where I put that. So now I don't have to just get user from the input over the serial monitor. I could set things based on where I put this potentiometer. So now all of a sudden it's like a little product where I could start turning that knob and getting the LED brighter or dimmer. I could turn the knob and that could affect how fast the LED blinks. I could set the parameters for the operation of the circuit from this from a potentiometer like this. So even though this is real simple, this is extremely powerful because it lets a device work sort of autonomously, that on the circuit you can start getting your input directly from the circuit. Okay, let's just take a quick look though. What you might want to do is you might want to turn this read value, like I think in terms of 0 to 1023, so I can look at it and I can just see what the voltage is. But if you were going to give it to a user, you might want to give them a number from 0 to 5 volts. And so let's see how that math works, all right? Well, again, we go back and we use what we learned with linear equations. Let's think about what you read. You read a value from 0 to 1023. And so we're going to make this axis, the horizontal axis, your independent variable. That's what you read. It's your read value. And then that corresponds to a real world voltage between 0 and 5 volts. And so we make that the vertical axis. Voltage between 0 and 5 volts corresponds to read value of 0 to 1023. Well, let's see if we can find 2 points on here. Point number 1, we know that a read value of 0 corresponds to a voltage of 0. So we have 1 point, the point 0, 0. All right. What's the second point we know? The second point we know up here is that a read value of 1023 corresponds to a world voltage of 5. So we have a second point of 1023, 5. So we have 2 points for this line. If we have 2 points, we can calculate a slope. Slope is y2 minus y1 over x2 minus x1. That's going to be equal to, let's have this as the second point and this is the first point. Makes it a little easier. I like to do my linear equations to try to avoid negative numbers. So I have 5 minus 0 over 1023 minus 0. So that's y2 minus y1, y2 minus y1 over x2 minus x1. And that comes out to be 5 over 1023. Now we know the slope, the point slope form of a line is y minus y1 is equal to m over m times x minus x1. Your point x1, y1, you could pick this point or you could pick that point and you'll get the same answer. But it's a lot easier if you pick the easier point. Let's pick this one. All right, now let's put in the values. Y minus y1 is m onto x minus x1. Y minus 0, right? Okay, that's 0, is equal to 5 over 1023, which was the slope, times x minus x1, right, times x minus x1. So we have 5 minus 0 is equal to 5 over 1023, the slope, onto x minus 0. And that's because we chose this point of 0, 0 to make it easier. The other one would have eventually given us the same answer. So y is equal to 5 over 1023 times x. That is the equation of this line. Now the only thing I'm going to do now is just switch it to our y-axis. Y was voltage and x was read value. So we change y for voltage and x we make read value. So what we see is the real world voltage is equal to 5 over 1023 times the read value. Okay, and these are the read values that we're getting here. And so we can use this equation that we got from using that equation of a line that you've had to learn probably since 7th grade and wondered when you were ever going to use it. Well, you're using it now to allow you to really create an equation that will take this read value, this read number that we're getting that's between 0 to 1023, and turn it into a real world voltage, that's between 0 and 5. So let's go ahead and see if we can do that. So we've got our read value. Let's create another variable called integer, and it's our voltage, and this is our real voltage. We're going to calculate this, so we are not going to assign a value to it. We're just going to declare it. Okay, declare our voltage variable. Okay. Now, notice how I did an int just out of habit, but I want you to think about this. Are we interested in just the voltage 1, 2, 3, 4, 5? Or could we have in-between voltages? Well, very much we could have in-between voltages, and we could have a whole lot of in-between voltages. We could have 0.1 volts, 0.2, 0.3, 0.4. We could have very, very, very small increments in voltage, and so really we want the in-between number, so we should not declare this an int. We should declare it a float. And again, when we declare something as float, that means a floating point number. If we go back to math class, that would be equivalent to a real number. It's all the in-between numbers, and we call them floats in programming language. So we have a float variable. Now, we're going to calculate what is our real world voltage. Well, the voltage is going to be equal to, remember, it's going to be 5 over 1023. But now this is very, very, very important, and I mean, over and over I see students forget to do this. If we are declaring something to be a float, and if we are using floating numbers, we have to write our numbers as floating numbers. So instead of saying it's 5 over 1023, that's 5 over 1023. When Arduino sees 5, it sees it as an int, and when it sees 1023, it sees it as an int. And so if you do the int math, the integer math of 5 divided by 1023, it's going to come back with a 0 because it's going to round it to 0, or it's going to truncate it to 0. And so you don't want it because you want a real floating point number. Well, we've said voltage is floating point, so we need to make these floating point numbers, and we do that by putting a decimal. 5 point tells Arduino that you want the floating point number 5, not the integer 5. And similarly here, point. So when you are doing floating point math on the Arduino, make sure that you put your decimal in, or you're going to get some surprising results that's going to take a long time to figure it out. So what was it? Voltage is equal to 5 over 1023 times read value. And so we have 5 as a float divided by 1023 as a float, and then we're going to go times read value. Okay? And then we're going to do, this is, what is it doing? It's calculating the real world voltage. Okay? Now, let's download this and see if it's still happy. Looks like it's going to be happy. See if we can get our serial monitor back up. Call that thing up. All right. Now look, ooh, that does not look good. Let's see. Let's try downloading it again. I see what I did. I was still printing read value. So even though I calculated voltage, I was still printing read value. So that was a little bit of a shocker to me. So what we've got to do is, we don't want to print out the read value anymore. We want to plot out serial dot capital S serial dot print line, and then we want to print voltage. Okay. Print out the real world voltage. Okay. This should work this time. So this time we should be getting values. Ooh, somebody should have told me. Semicolon at the end of almost all lines. Okay. So now we should be getting real world voltages. Print this out. Okay. That looks happy. Let's call this up. Okay, so remember how that was a read value of about 520 something? Well, that corresponds to about 2.5 volts, so we're just sort of almost halfway up. So if I turn it all the way, let me get the circuit back here where you can see the circuit. Get this all in here. So if I turn this all the way to the left now, you can see that I have 0 volts. I can turn it just a little bit, and look at that, I'm getting about, let me see if I can get it. Okay. That's about as close as I can get it, but I'm getting about 1/10 of a volt there. So you see why we needed floats, because we need the numbers between the integers. And so now I can turn it up and I can get 0.5 volts. That's like, let's see, I can get about, I'm trying to get about 0.75. It's kind of hard to get it exactly, about 0.75. I can take it up to 1 volt, take it on up, keep turning to the right, keep turning, keep turning, keep turning. and I get 5 volts. So you see, what I'm doing is I've got this potentiometer, okay? I did the math, and it was based on this voltage divider that we talked about, okay? Let's see if we can get it all showing here. And I'm reading now an analog voltage off of that voltage divider, and I'm reading it in real volts from 0 to 5 volts. So I'm reading an Arduino number that's between 0 and 1023, and I'm converting that to a real world voltage between 0 and 5 volts. And so you see, it's like a little voltmeter that we've built here, and the voltage corresponds to whatever voltage that this analog pin reads. Well, let's just do an experiment, okay? What if I just unplug this from the potentiometer, okay, and I put it on my ground? What should it read if I put on the ground? It should read 0 volts. I didn't put it on the ground. If I put it here on the ground, right there, it should read 0 volts, and it reads 0 volts because ground is 0 volts. What if I put it on the next one down at the positive rail, and when I put it in there, it reads 5 volts. So you see, all of a sudden here with this little pin, I have a little voltmeter that'll read anything between 0 and 5 volts, okay? So I'm going to come back in here and put it on my potentiometer again. But really, you would not use this as a to build a voltage supply, really. Really what you're doing is you're trying to basically read and understand where the potentiometer is set to. And what you're really going to use this for usually is for an input on your circuit. So like, let's say that I could write a little program that if I have it turned to the left, the LED blinks really slow, and as I turn it to the right, the LED starts blinking faster and faster. And so basically, this is a way that you can start controlling things with knobs. There's all types of different reasons that you would use, that you would do these analog reads. Just to recap, remember when you're doing an analog read, you have to use one of these 6 pins, A0 to A5. You have to use one of those if you're going to do an analog read. These pins down here will do digital writes. The ones with the squiggly lines will do analog writes, and the ones that do not have the squiggly lines will just do digital writes. And so squiggly line on this bottom set of pins will do analog writes or digital writes. The ones without the squiggly lines will do only digital writes. Okay, so this is a powerful tool, new tool we have now. We can talk to the user over the serial monitor. We can read values from the serial monitor. We can apply voltages, digital voltage to pins. We can apply analog voltages to pins, and now we can read analog voltages. So our tool set is getting pretty sophisticated, and we're going to be able to do some pretty impressive things with these simple tools fairly quickly. Okay, again, I am Paul McWhorter. This has been lesson number 10, and hope you will tune into lesson number 11 very shortly.